So you're telling me after I spent so long recording, I have to edit this now. Guys. Question 1. For the inductive steps, which of the following is true? A. Base case, n equal 1. Assumption case, n equal k. Implication case, n equal k plus 1. B. Base case, n equal 2. Assumption case, n equal k. Implication case, n equal k plus 1. C. Base case, n equal 3. Assumption case, n equal k. Implication case, n equal k plus 1. Or D. None of the above options. So these are our 3 steps: base case, assumption case, implication case. Our base case is simply us showing that the statement is true for the first case, and this is usually n is equal to 1. Our assumption case is where we're assuming that the statement is true where n is equal to k, and k is some large number. And our implication case is simply us using our assumption to show that the statement is true for n is equal to k plus 1. Therefore, based on this, the answer to our question is simply option A. Question 2. Suppose our induction question is stated as the sum of any 3 consecutive numbers is divisible by 3. Which of the following is true? A. This can be represented as 3 times in brackets n plus 1, where n is a member of real numbers. B. This can be represented as 3 times in bracket n plus 1, where n is a member of natural numbers. C. This can be represented as 3n plus 1, where n is a member of natural numbers. Or D. All of the above options are true. So this is our induction question. The sum of 3 consecutive numbers is divisible by 3. What does the word consecutive means? Consecutive simply means one after the other. So if we're thinking about numbers like 1, 2, and 3, we could call those numbers consecutive. Why? Because we have the number 1. What comes after 1? 2. After 2, 3. So it's like we're adding 1 each time. So if we're thinking of consecutive as adding 1 each time, let's say we have a number, some number n. What number comes after n? It would simply be n plus 1. What number comes after n plus 1? That would be n plus 1 plus 1, which would be n plus 2. Next, we're going to add these terms because we want the sum. So we're going to have n plus 1 plus n plus 2. Simplify this, we're going to have, in fact, let me put the n's together. So I'm going to have n plus n plus n plus 1 plus 2. Next is we're going to simplify. So n plus n plus n would give us 3n. 1 plus 2 would give us 3. From here, we see a common factor being 3. That means we're going to factorize 3. So we're going to have 3, and then in bracket, we're going to be left with n plus 1. And that's the expression we get when we add these consecutive terms. From the options given, we're seeing 2 options that have this expression, 3 times in bracket n plus 1. Those options are A and B. However, the difference between these options is the set that n is a part of. In A, n is a part of a set of real numbers. However, in B, n is a part of a set of natural numbers. So the question you might be asking now is, what set is n a part of? So we're going to do this simple example. So right here we have, basically if n is a part of a set of natural numbers, we have 3 consecutive natural numbers. If n is a part of a set of real numbers, which is a broad set, because recall that a natural number is a part of a set of real numbers. However, real numbers also include rational numbers, irrational numbers, integers, etc. So yeah. So if n is a part of a set of real numbers, we would have this. So 4.5 plus 5.5 plus 6.5. I'm going to find out if these two are divisible by 3. So when we add 4 plus 5 plus 6, we're going to have 15. 15 is divisible by 3. Why? Because we can write 15 as 3 times 5. And we know that 5 is an integer. So 5 is a part of a set of integers. Next, we move on to this. So what is 4.5 plus 5.5 plus 6.5? So this would give us 16.5. Is 16.5 divisible by 3? Let's see. So when we divide 16.5 by 3, we're gonna be left with, not left with, but we're gonna have 5.5. Is 5.5 an integer? No, because there's a decimal place there. And usually with a decimal, or if we have like some fraction, if we express that as a fraction, that would simply represent our remainder. So therefore, since this is not an integer, this is not divisible. 16.5 is not divisible by 3, and it is not true for n is a part of a set of real numbers. Therefore, our answer is B. Question 3. 3 plus 6 plus 9 plus 12 plus ... plus 3n is equal to 3 over 2 n times in brackets n plus 1, where every n is a part of a set of positive integers. In terms of summation, which of the following is true? So this is our statements. We have the left hand side and the right hand side. And this question is basically asking us to rewrite our left hand side in terms of sigma notation, also known as summation. And yeah, that's what we're gonna do. Guys, I have a secret to tell. You can't tell anyone. I did a video on mathematical induction, and I reviewed how to represent a series in sigma notation. You should watch the video. That's it. Yeah, so of course we'd have our symbol. In the middle, we should know that the formula goes there. The formula is used to determine each term of the series. To determine what is the formula, we're simply going to look at our last term, and where we say n, we're going to change it for a different variable. Never, oh my gosh, never put some n term there. Never put this here. Never do that. You're changing n for a different variable. Always. So I'm gonna have the variable I as my variable, and that's our formula. Next, down here would have our lower limit. The lower limit is simply the first number we substitute in the formula to get our first term. Since our first term is 3, that would mean that the first number we substitute in the formula would be 1. Because 3 times 1, the 3 times 1 would give us 3. And that's our first term. Therefore, our first number is 1. And then up here would be our upper limit. So that's where we have the last number we substitute in the formula to get the last term of the series. Since we have 3n being the last term of the series, that means that n was the last term we substituted in the formula. And that's what we have. Therefore, based on our answer right here, the option that has this as well is B. So B is our answer. Question 4. 1 times 3 plus 2 times 4 plus 3 times 5 plus 4 times 6 plus ... plus n in bracket times in brackets n plus 2 is equal to n times in bracket n plus 1 times in bracket 2n plus 7 all over 6. The expression for the implication case would be, and we have the options. We have our statement right here, and the question is asking for the implication case. However, before we get into that, let's write our left-hand side in terms of sigma notation. So of course, we're gonna have our symbol. Our formula goes right here. We look at this last term, I'm gonna change out n. And in this case, I'm gonna use j. So j in bracket j plus 2. Next, lower limit would simply be 1, and upper limit would be n. So that is our sigma notation for the series, the left-hand side. Next, since the question is asking for implication, recall that in the implication case, we used our assumption to show that n equal k plus 1 is true. Therefore, in order for us to know our implication case, we'll have to know our assumption. So that's what we're gonna look at right now. So we have our assumption case, and this is where n is equal to k. So wherever we say n, we're gonna put k. So k would become our upper limit for this, and would have our formula and lower limit as it is. Next, we should recall that this expression, this notation right here, is representing 1 times 3 plus 2 times 4 plus 3 times 5 plus 4 times 6 plus ... plus our k term. What is our k term? We can determine our k term by simply substituting k into our formula right here, because recall that the formula is used to determine each term of the series. So we'd simply substitute k into this, and we're gonna have k in bracket k plus 2. So this summation can be written as this as well. So now let's look at our implication case, now that we know our assumption. Okay, so implication case, this is where n is equal to k plus 1. So wherever we say n, we're gonna put k plus 1. So let's do that first. So we have k plus 1 as our upper limit, have the formula, have the lower limit. So now we want to know what is this equal to. So recall, we know the sum of terms from 1 times 3 all the way down to the k term. In order to find out what is the sum of terms from 1 times 3 to our k plus 1 term, we could simply have this notation and then add our k plus 1 term. So let's actually discover what is our k plus 1 term. Recall that the formula right here is used to determine each term of the series. And all we have to do is substitute our k plus 1 in the formula. So that's what we're gonna do. So we'll have j times j plus 2. So where we see j, we're gonna put k plus 1. So we're gonna have k plus 1. Can you guys see? K plus 1. And then in bracket k plus 1. And then the plus 2. Simplify that, we'll have k plus 1. And then k plus 3. So this would be our k plus 1 term. So that's what I'm going to call it. K plus 1 term. And this is, of course, our k term. So now that we have established that, we can say that this is equal to this plus, so I'm going to put that in brackets, plus our k plus 1 term being the k plus 1 times k plus 3. Therefore, this would be our answer. So we're looking for the option that has this. We see D having this answer. Guys, I have another secret to tell. If you want to understand this question more, you can go to my mathematical induction video and look at the examples. You can look at, specifically, I would recommend example 2 or 3 under the series formula section of the video chapter. So, don't tell anyone though. Question 5. Given the statement 13 to the n minus 1 is divisible by 12, where every n is a part of a set of natural numbers, if t is a part of a set of integers, then the solution for the implication case would be, and we have our options. Here we have it. 13 to the n power minus 1 is divisible by 12. And the question is asking for the implication case. Recall that in the implication case, we use our assumption. Therefore, we'd have to go to the assumption case to determine the implication case. So let's do that. So here we have our assumption case. This is where n is equal to k. Therefore, wherever we say n, we're putting k. So we're going to have 13 to the k minus 1. And this would be equal to, recall that a number is divisible by 12 when we can write it as 12 times an integer. From the question, we're told that t is an integer. Therefore, we can write this expression as 12 times t. And we know that t is a part of a set of integers. So now we move down to the implication case, and this is where n is equal to k plus 1. Therefore, where was the n? We're going to put k plus 1. Wherever we see n, we're putting k plus 1. So we're going to have 13 to the k plus 1 minus 1. 13 to the k plus 1, using our indices law, we should know that this is equivalent to 13 to the k multiplied by 13 to the first power. Because when we're multiplying two numbers of the same base being raised to a power, we can simply have the numbers and add the powers. And of course, we're gonna still have our minus 1. And we're gonna have 13 to the k times 13 minus 1, because it's the same thing. Next, recall that in the implication case, we're always trying to find a way to use our assumption. Since our assumption states that 13 to the k minus 1 equal 12t, we can make 13 to the k the subject of the equation and substitute it into here. So we're going to have 13 to the k equal 12t plus 1, because we're bringing it over the other side. So since 13 to the k is equal to 12t plus 1, we can substitute right here, and we're going to have 12t plus 1 times 13 minus 1. I'm going to multiply these. So what is 12 times 13? This would give us 156t, because we have the t there. And then we're going to have 13 times 1, that would be 13. And of course, we'll have the minus 1. 13 minus 1 would give us 12. So we're going to have 156t plus 12. From here, we're going to factor out 12, because recall that if an expression number is divisible by 12, we can write it as 12 times an integer. So that's what we're going to do. We're going to factor out 12. When we factor out 12, we're left with 13t plus 1. And of course, 13t would be an integer, because we know that t is an integer. So because of that, we'd simply have that the 13 to the k plus 1 minus 1 is equal to 12 times 13t plus 1. And what option gives us that? Option A. So that would be our answer. Question 1. Which of the following is a singleton set? So a singleton set is simply a set that only has one element. So we should know that a set is usually represented by curly brackets, and of course we're gonna have the element in the middle. Therefore, the answer to our question here is option A. Question 2. Let A and B be any two subsets of the universal set U, and A is a subset of B. Which of the following is not true? A intersect B equal A, B, A union B equal B, C, B minus A equal B, or D, A minus B equal empty set. So in this question, we're told that A and B are subsets of U, the universal set, and A is a subset of B. So of course, this is the symbol for subsets. So I'm going to draw a little Venn diagram for this to represent the information given. So this is our universal set, and of course, since we know that A is a subset of B, therefore the set A would be inside of B. So this is our B, and this would be our A. So that's how the Venn diagram would look like. So the question is asking us which of the following options is not true. So the first option says A intersect B equal A. So we're simply looking at what these two sets have in common, and we're seeing that set A is the intersection. So based on the diagram, let's highlight the intersection. So what does set A and set B have in common? Since A is a subset of B, the intersection would simply be A. Therefore, option A is true. Option B, A union B equal B. Union simply means that we're considering all elements of both sets. And since A is a subset of B, meaning that all of the elements that are in A are also in B, that would simply mean that B would be our union. Therefore, option B is true. Option C, B minus A equal B. So B minus A is simply means that we're considering the elements of B that are not in A. So that would mean that it's B minus everything in A. So it's like B alone. So we're gonna shade this part. We're not gonna shade A, which is in the middle. So the option C is telling us B minus A is equal to B. Recall that B is every single thing here. So B also includes A because A is a subset of B. Elements that are in A are also elements of B. Therefore, with this option, to say that B minus A is equal to B, that would be false because we're not considering everything that is in B. Another thing we can note is that B minus A would be the same thing as saying B intersect A complement. A complement is all the elements that are not in A. So it's like us considering the universal set and we're subtracting A. When we have B intersect A complement, we're considering the elements of B. That means that, everything that is not in A intersect B would give us B alone, which is right here. So these two are equivalent. And of course, let's look at option D. So A minus B equal empty sets. So this is telling us all of the elements of A that are not in B. A is a subset of B. That means that all of the elements that are in A are also in B. That means that this would be an empty set and option D is true. So our answer to this question is C, B minus A equal B. That's false. Question 3. Consider the following set. 5x minus 1, where x is a member of a set of integers. Listing the elements of this set, we obtain, and of course we have our options. Okay, so here we have our set, 5x minus 1, where x is a part of a set of integers. So the first thing that probably comes to your mind, let's substitute 1 into this expression and see what we get. You get 4. We see an option that starts with 4. A is the answer. No. What is an integer? An integer is positive numbers, negative numbers, and 0. 1 is the first positive integer. But remember, integers are also negative, integers are also 0. So we would have to consider negative numbers as well. And you see options where it starts with negative 11. So you might be thinking, let's substitute minus 2 into this and we get negative 11. So perhaps option B is our answer. Another thing we should note, a set of integers is an indefinite set. So if we're supposed to consider this specific set, there should be some indication that the set is indefinite. And that's usually with the ellipsis at the beginning and at the ending. Because do we know what's the first negative integer? Negative a billion is an integer. Negative 3 million is an integer. We don't know. It's an indefinite set. So that means if we're supposed to consider the number line, the negative side and the positive side, for a set of integers, it would go on and on and on. Therefore, the answer to this question, we'll have to look for an indication that the set is going on and on the negative side and the positive side. There's only one option that has that, and that's option C. Therefore, option C is our answer. Question 4. Given that S equal X is a member of natural numbers where X squared minus 1 equals 0, the number of elements of S equal, and we have the options. So here we have the set S, and this is equal to X is a member of a set of natural numbers where X squared minus 1 is equal to 0. So All this question is asking us to do is to solve the equation, and the solutions that we get for x basically should be a natural number. So we should basically just consider where x is a natural number to answer this basically. So we're going to solve the equation x squared minus 1 equals 0. We're going to bring 1 over the other side, so we have x squared equal 1. We're going to square root both sides, and when we square root any number, there's always going to be a positive root and a negative root. So we're going to have that there. So when we square root that, we have x is equal to positive 1 or negative 1. Recall that the set is telling us that x is a member of natural numbers. We start natural numbers from 1. So no negative number is included in natural numbers. Therefore, for this set, we're only considering the solution x is equal to positive 1. And for the number of elements that is a part of the set is 1 would be our answer. So our answer would be B. Question 5. If a equal negative infinity 279 and as in an open interval, and a is a subset of real numbers, then a complement equal. So here's our first question with interval notation, and let's just highlight a few things first. So when we have a curved bracket like this is basically telling us that this is an open interval, meaning that the whatever number you see on this side right here, when you have it right here beside the open interval brackets, it's not included in the set. And same thing goes for this side. The 279 would not be included. If we had, for example, the squared brackets now, and we had a number here and a number here, like we usually do, this is telling us this is a closed interval, and it's telling us that the element right here, that would be right here, not element, but yeah, the number that would be right here would be a part of the set, and the number right here would also be a part of the set, because we have the square brackets, it's a closed interval. If we're to have the open interval and then the closed interval, like the brackets, the element that would be right here, closer at the beginning basically, would not be included because we have the open interval bracket right there. However, the element right here would be included because we have the closed interval bracket. And the same thing would go for this one, in a sense that the element right here would be included because we have the closed interval bracket, and the element right here would not be included because we have the open interval bracket. So we have this open interval, and with these questions, it's always good for us to draw a diagram, specifically a number line. So we're gonna have our number line right here. This is the number line of real numbers. And we're gonna highlight the number 279. So with this, since right here, we're seeing that 279 is not included in the set, that would mean that we'd have an open circle right here to highlight that it's not included. And recall that this is negative infinity. So that means that this expression right here would be the same thing as saying that any element that is a part of A is less than 279, because we're going this direction. This is negative infinity, this is positive infinity, and yeah. So yeah, that's our diagram. And the question is asking us for a complement. So since we're saying that, right here, if we have an element x that's a part of this set, we're saying that x is less than 279 for A. So if we want to consider a complement, that would be the total opposite, meaning that we would have this being shaded to show that it's included in the set. So just make a note, this is A, this is going to be a complement. We're going to have this shaded, this shaded to show it's included in the set, and then we'd have the arrow in the opposite direction. So if this is shaded, it's telling us that 279 is a part of the set. So that would mean that x would be equal to, and it's going in the opposite direction. So since this is in the less than direction, this would be in the greater than direction. So x is greater than or equal to 279. And of course, that would be our answer. And yeah. So what option has the answer? The option with the answer is option A. Question 6. If A equal negative infinity, 13, and that's in an open interval, and B equal negative 5 and 81, where there's a closed interval bracket where negative 5 is, an open interval bracket where 81 is, then B minus A is equal to... Okay, so here's our question. We're given that A is equal to negative infinity and 13. That's the interval for A, and then B is negative 5, 81. And the question is asking for B minus A. So the first thing we'd have to do is draw our diagram, being the number line, to highlight, to basically represent these two intervals. So we're gonna just put 13, okay, have negative 5 here, have 13, have 81. Right? We're gonna represent set A on this number line. So we'll go to 13. There's an open interval bracket there, so that means that it's not included. So we'll have the open circle, and this is negative infinity. So it's telling us that we're going in the negative infinity direction. So that would be A. And B, we'll have negative 5. We'll have the closed interval brackets, that means it's included. So we're gonna shade that part. And we're going to 81. So, and where 81 is, we'd have an open circle. So that's our B. And we want to find out what is B minus A. So we're considering all the elements that are in B that are not in A. So we're looking at, this is where A and B would basically intersect. Since we want B alone, we're looking at this region right here. So from where we have the two numbers. So we're gonna take the 13 and the 81. And all we have to do is determine whether 13 is included in the set and 81 is included in the set. So that's all we need to determine. For this question, remember that you're always trying to take a number that's on the number line to be representing the interval, basically. You're never gonna take, for example, 14 or 15 or 82 or 80. You're never doing that. Okay, so we're saying that B minus A. So we know that 13 is a part of B, and 13 is not a part of A because we'll have the open circle there. That means that we'll have the closed interval bracket there. Next, for B, we'll have 81, we'll have an open circle right there, and open circle means that it's not included, so we'll have the curved bracket there. So this would be your answer to the question, closed interval bracket 13, 81, open interval bracket. And the option that fits our answer right here is option C. Question 7. Given that U equal, where x is a real number, x is greater than or equal to negative 3 and less than or equal to 2. A equal, x is a real number where x is greater than negative 3 and less than or equal to 2. And B, where x is a real number, x is greater than or equal to negative 2 and less than 2, where A and B are subsets of the universal set U. What is A complement intersect B complement? So this is the information we're given. We have the universal set where x is greater than or equal to negative 3 but less than or equal to 2. We'll have two subsets of the universal set, being A and B. A is where x is greater than negative 3 but less than or equal to 2. And B is where x is greater than or equal to negative 2 but less than 2. And we want to find out what is A complement intersect B complement. So from here, let's draw our number line, basically, and we want to represent this as the universal set because we know that A and B are subsets of the universal set. So right here, we're gonna have negative 3, and right here, we're gonna have 2. So we're told that x is greater than or equal to negative 3. So the equal to basically indicates that negative 3 is included in the universal set. So we're gonna have a shaded circle right here. And we'll have x is less than or equal to 2. The equal to basically indicates that 2 is included in the set. So we're gonna have a shaded circle where 2 is. And that's our universal set. Next, let's represent our subsets, A and B. So A is where x is greater than negative 3. So we're saying that x is just greater than negative 3. There's no equal to. So that means that negative 3 is not included in the set. So we're going to have an open circle above the negative 3. And we have x is less than or equal to 2. The equal to indicates that 2 is included in the set, so we're going to have a shaded circle above the 2, and that would be A. Yeah. And then we have B. So B is where x is greater than or equal to negative 2. So let's have our negative 2 point. And we're saying that x is greater than or equal to negative 2. So we're going to have a shaded circle since negative 2 is included. And then we have x is less than 2. Since we're just saying x is less than 2, meaning that 2 is not included, we're going to have an open circle. And that would be our set B. And we want to find out what is A complement intersect B complement. Before we find that out, we have to know what is A complement and what is B complement. So recall that A complement is simply all the elements that are a part of the universal set that are not a part of A. So this is the same thing as us saying the universal set minus A. All elements that are a part of the universal set that are not in A. And then B would be similar, so we have all elements that are a part of the universal set that are not a part of B. So universal set minus B. And let's find what is A complement. So A complement, we're looking for where we're looking for the elements that are not included in A. So we realize that from here, the length of A is the same as the length of B. However, the only difference between the universal set and A is that there's an open circle above the negative 3 for A. That means that negative 3 is not included in A, and since that's the only difference between the universal set and A, that tells us that negative 3 is not included in A, so it would be included in A complement. Next, we move down to B complement. So we're considering all the elements that are a part of the universal set that is not a part of B. That are not a part of B. So we're gonna see where B is, and we're gonna consider all the elements that are not a part of it. So we see an open circle right here. The open circle tells us that 2 is not a part of B. That means that 2 would be a part of B complement. So let's have 2 right there. Next, we realize that B basically stops or starts right here. However, we have the negative 3. We have this region right here where B is not covering. So we have negative 3. Since negative 3 is not included in B, that would mean that negative 3 is a part of B complement. So we're going to have an interval. We'll have the closed interval bracket, and we'll have negative 3. Next, we'll have negative 2. Negative 2 is a part of B. That means that negative 2 is not a part of B complement. So we're going to have the negative 2 and an open bracket. And yeah, we're going to have a union symbol right here to show that this is everything for B complement. Now we want to know what is A complement intersect B complement. So what does A complement and B complement have in common? So realize that A complement simply have one element, and that's negative 3. We're going to look for if B complement also has negative 3. B complement also have negative 3 because we have the squared interval here that indicates that negative 3 is included in the set. So the answer to this question would simply be a set that just has negative 3. So in this case, our answer would be D. And our final question in the section, question 8. So notice we're given the same information as question 7. However, in this case, we're simply determining which of the following is true. The first one is A complement equal negative 3, a set that only has negative 3. 2, B complement equal closed interval negative 3, negative 2, open interval union, a set that only has 2. 3 equal A minus B equal open interval negative 3, negative 2, closed interval union, a set that only has 2. And then the number 4, the fourth one, is B minus A equal empty set, and we want an empty set. And our fourth one, B minus A equal an empty set, and we want to know which of the following is true. So here's our question, and from the previous question, question 7, we know that A complement is a set that only has negative 3. Therefore, the first one would be true. And then for B complement, we know that this is closed interval, -3, -2, open interval, union, a set that only has 2, which is the same thing as 2 right here. So this would also be true. So all we have to do is to determine if the third one and the fourth one are true. So the third one says A minus B is equal to open interval -3, -2, closed interval, union, a set that only has 2. So we're gonna look right here. We're looking at the elements that are in A that are not in B. So we're looking at this part. Simply, yeah, we're looking at this part to see the elements that are in A that are not in B. And of course here, because 2 is not in B. So from here, we know that -3 is not included in A because we see an open circle right there. We have the open interval bracket here, so yeah, that's correct. Next, we're looking at -2. We know that -2 is a part of A. However, -2 is also a part of B because we see the shaded circle. So since we have a closed interval bracket right here, that would be false. Why? Because -2 is also in B, and we're looking for the elements of A that are not in B. So immediately we know that this would be false. So now let's look at the fourth one. B minus A equal an empty set. So B minus A is simply telling us that we're trying to find what is all the elements of B that are not in A. And since this is an empty set, we're saying that all elements that are in B are also in A. So let's see if that's true. So we have B right here. This is B. And we're looking for where B alone, basically, where B doesn't include A. So we know that from here, we have -2, and -2 is included in B. However, -2 is also included in A. That means that -2 will not be a part of the set. And we're going all the way down to 2. We know that 2 is not included in the set. So that means that it basically shows us that all the elements that are a part of B are also a part of A. So it's an empty set. So this would be true. So based on this, we know that the first one, the second one, and the fourth one are true. And what option has 1, 2, and 4? Option B. So option B is our answer. Question 1 of section 3, functions. Given that A equal a set of members 1, 2, 3, and 4, and B equal a set of members A, B, and C, and that R maps A to B, which of the following relation is not a function? Option A, 1A, 2B, 3C, 4B. Option B, 1B, 2C, 3A, 4A. Option C, 1A, 2C, 3B. Or option D, 2A, 1B, 3A, 4A. Here's our question, and we're told that R maps A to B. So that means A is our domain and B is our codomain. So we want to know which of the following is not a function. So a function is a relation where x values, it could be one or it could be many x values, maps onto one single y value. So one element of the domain or many elements of the domain maps to one single y value. It has to be one y value, one element of the codomain. And a function is a function when all elements of the domain maps onto one element of the codomain. So all elements of the domain have to be mapped onto a y value. Okay, so let's look through the options. So we have option A, and we have the ordered pairs 1A, 2B, 3C, and 4B. So we'll have to check first. Let's check if all the elements of the domain are being mapped onto a y value. So this is our domain. Set A is our domain. So we'll have to ensure that 1, 2, 3, and 4 are being mapped to a y value. We see 1 here, we see 2 here, we see 3 here, and we see 4 here. So all of them are being mapped onto a y value. Next, we'll have to ensure that there is either a one-to-one relation or a many-to-one relation. So all we're saying is that the same x value shouldn't be mapped onto many y values. So for example, we have 2 and we have 2b. We shouldn't say 2b and 2c. We shouldn't see one single x value being mapped to many y values, because that is a one-to-many relation, and a one-to-many relation is not a function. So here we have it. So we have 1 being mapped to A. Do we see 1 anywhere else? No, so that's good. We see 2 being mapped to B. Do we see 2 anywhere else? No, so that's okay. 3 being mapped to C. Do we see 3 anywhere else? No. And 4 being mapped to B. Do we see 4 anywhere else? No. So that means that this is a function. And you're probably wondering, what about the 2 being mapped to B and 4 being mapped to B? That simply highlights a many-to-one relationship, where many-to-one relation where we have many x values being mapped to one single y value. Once we have many x values or one x value being mapped to one single y value, it's a function. So option A would be a function. So that's not our answer. Next, we move down to option B. So we have 1b, 2c, 3a, 4a. And we're looking for, let's ensure that all the elements of the domain are being mapped onto a y value. So we see 1, 2, 3, and 4. Those are all the elements of the domain, so that's good. Next, we're looking for a one-to-one relationship, or one-to-one relation, or a many-to-one relation. We're ensuring that we're not seeing a one-to-many relationship where we have one single x value being mapped to many y values. We should always have one single y value. So we have 1 being mapped to B. Do we see 1 anywhere else? No. So that's good. We see 2 being mapped to C. Do we see 2 anywhere else? No. So that's good. We see 3 being mapped to A. Do we see 3 anywhere else? Is 3 being mapped to any other element? No. So that's good. And we have 4 being mapped to A. Is 4 being mapped to any other element of the codomain? No. So that's good. So that means that option B is also a function, and it's okay to have 3 and 4 being mapped to the same elements of the codomain A, because that simply highlights a many-to-one relationship, and a many-to-one relation or relationship is a function. Remember, one-to-one, many-to-one, function. As long as we're not seeing the same x value being mapped onto many y values. So we shouldn't see, for example, 3a and 3b. That would make the relation not a function. So option B would be a function. So that's not our answer. We move down to option C. So we have 1a, 2c, and 3b. First, we have to check if all the elements of the codomain are being mapped onto a y value. This is our codomain 1, 2, 3, and 4. We have 1, we have 2, and we have 3. Where's 4? Since 4 is not being mapped to a y value, that means that this is not a function, because a function has all its elements, all the elements of the domain being mapped to a y value, being mapped to a codomain value. Codomain elements. Yeah. So since this is not a function, this would be our answer. And let's just look at option D. So we have 2a, 1b, 3a, and 4a. So we have all the elements of the domain being mapped onto a y value, and we're not seeing the same x value being mapped to some different y value. So for example, we're not seeing 2a, we're seeing 2a, but we're not seeing, like, for example, 2b or 2c or anything like that. So this would be a function as well. So our answer is simply C. Question 2. Suppose that A equal the set of elements 0, 1, 2, 3, 4. B is the set of elements 2, 3, 4, 5. And F is the set of ordered pairs 0, 3, 1, 3, 2, 4, 3, 2, and 4, 2. The domain and range of F and f of 1 and f of 2 are, and of course we have the options. Option A, domain is 1, 2, range is 3, 4, f of 1 equal 3 and f of 2 equal 4. Option B, domain is A, range is B, and f of 1 equal 3 and f of 2 equal 4. Option C, domain is A, range is 2, 4, 5, f of 1 equal 3 and f of 2 equal 4. Or D, domain is A, range is 2, 3, 4, f of 1 equal 3, and f of 2 equal 4. Okay, so here's the information we're given, and we want to find out what is the domain and range of f, as well as f of 1 and f of 2. So recall that the domain is simply the x values. So if we look at the ordered pairs right here, the x value is usually the first value we see in the ordered pair. So notice that I underline them using a blue marker. So therefore our domain would be 0, 1, 2, 3, and 4. So since we have a set that has 0, 1, 2, 3, and 4, this set is the same thing as set A. That means that our domain is simply set A. Next, for our range. So that's the second value we see in the ordered pair. And notice I circled them in using a red marker. So elements of the range would simply be 3. I see 3 again, I don't have to write it again. So I'm gonna have 4, 2, and I don't have to write this one again. And let me just put these in order. So I have 3, 4, and 2. So I'm gonna have 2, 3, and 4. So that would be our range. And notice our range is different from set B. So set B is simply the codomain. And the codomain is the possible y values that elements of the domain can be assigned to. So the range are the actual y values that are assigned to our x value. Yeah. And we want to find what is f of 1. 1 is the x value. So we're going to see where x is equal to 1. Looking right here. So we see right here, x is 1 right here. What is the y value for x is equal to 1? 3. So that means that f of 1 would simply be 3. And we want to find what is f of 2. So we're going to see where x is 2. X is 2 right here. When x is 2, y is 4. So our f of 2 would simply be 4. And that would be our answer. So we're going to look for the option that has this answer. So from the options, we're seeing D. Question 3. The domain of the function f of x equal root of 1 minus x squared is, so we're finding the domain of the function. So we're trying to figure out what x values we can substitute in the expression, in the function, and get an answer. What makes the function, what x values make the function define or exist? We're gonna get an answer from the function when we substitute the x values basically. So in order to find out what x values make the function exist or defined, we'll have to consider what x values does not make the function exist. So when we try to substitute this x value in the function, we're gonna end up to have undefined as our answer, basically. So we'll have a square root sign and we'll have an expression under the square root sign. Please recall that we can't find the square root of a negative number. So that means that whatever number or expression we have under the square root sign has to be positive or equal to 0. So that means the expression under the square root sign should not be less than 0. It should not be negative. So since it shouldn't be less than 0, it has to be greater than or equal to 0. Because once we find greater than or equal to 0, so the root of 0 would be 0. So that's what we mean. That's what we mean. So greater than or equal to 0. Yeah, so we're gonna just solve this inequality to find the domain of the function. So I'm gonna bring the x squared over the other side to make it positive. So we have x squared is less than or equal to 1. And I'm gonna solve this. So in order to help me solve this inequality, I'm gonna find the critical points. So this, since we have basically a quadratic, this is a quadratic expression. I can factorize and find the critical points basically. So this is where the quadratic is equal to 0, basically. So I'm gonna have x squared is equal to 1. I'm finding the critical points. So when x squared is equal to 1, I can square root both sides. and I'm going to have x is equal to plus or minus 1. So my critical points would be x is equal to minus 1 or x is equal to 1. Next, in order to find this interval, the answer to this interval, I'm going to use a graphical method. So I'm going to have my critical points, the -1 and the 1. And since we're saying that the quadratic inequality is greater than or equal to 0, in fact, before we get into that, we'll have the square term being right here. Notice that we have a negative sign in front of the square term. This indicates to us that the coefficient of the square term is negative. And since the coefficient of the square term right here is negative, we'd have a maximum curve. This is a maximum curve. Next, we should know this is our x-axis. We should know that above the x-axis, our y values are positive, and below the x-axis, our y values are negative. Okay, so considering that, we'll have the expression 1 minus x squared is greater than or equal to 0. Since we're saying that this quadratic is greater than or equal to 0, we're looking at the values above the x-axis where the y values are positive, or right at the x-axis basically. So we're looking at this region right here. So from this region, we're gonna determine our interval. So I have -1 and 1. So from here, we can tell that this is a joint set. So we're gonna have that x is greater than or equal to -1 and less than or equal to 1. So this would be our domain, and what option has this domain? Option A. And you can always test if your answer is true. So we have the function 1 minus x squared. Let's take a number from this interval. So x is greater than or equal to -1. So let's consider a number that's a part of this interval, like 0. So we're going to substitute 0 into this. So f of 0 equal, wherever we say x, we're going to put 0. 0 squared is 0. So we're left with root of 1. Root of 1 is positive or -1. So that's our answer. That makes our function defined, so we're good. Next, let's consider a value, like for example, let's consider a value that is probably less than -1, like -2. So I'm going to substitute -2 in the expression. So I'm going to have 1 minus, then I'm going to have -2 squared. So -2 squared would give us 4. So under the square root, I'm going to have 1 minus 4. 1 minus 4 would give us -3. Can you find the roots of -3? No. So yeah, that's a number outside the interval. And we can also do this for, let's use the number 3. That's also outside the interval. So we're gonna have 3 where x is, so 3 squared. So I'm gonna have 1 minus 9. 1 minus 9 is -8. Can you find the square root of -8? No, because it's a negative number. So that's a number outside the interval. So yeah, that's us verifying our answer. So option A is our answer. Question 4. We want to find the domain of the function f of x equal 1 minus x over x squared minus 1. So just like the last question, we're finding the domain of this function, and we'll have f of x is equal to 1 minus x over x squared minus 1. And we'll have to find the x values that make this function undefined. And basically by us finding the x values that make this function undefined, we can basically determine an interval that makes, where we find x values that makes the function defined. So let's just get into it. So we have the expression 1 minus x over x squared minus 1. Recall that we have a function. What makes a function undefined? A function is undefined when we have 0 as the denominator. We can't find an answer when 0 is the denominator. Therefore, our denominator should not be equal to 0. So we're going to have x squared minus 1 should not be equal to 0. So we're going to find the x values that basically make the denominator equal 0 and exclude that from our domain, basically. So we're going to have x squared minus 1 equals 0. X squared equal 1. Square root both sides, we're going to have x squared, x is equal to plus or minus 1. So that means that these values should be excluded from the domain. Let's just make a note of that. Exclude from domain. So considering this, let's draw a little number line or something. Yeah. We have the number line. This is the number line of real numbers. So of course we're gonna have negative infinity and positive infinity. So we're gonna have negative 1 and 1. And all we're seeing is that for the domain, we're excluding these numbers. So we have the open circle there to show that it's not included. So that means that every other number is included in the domain. So all we have to do is represent this in interval notation. So since we're seeing that every other number is included except negative 1 and 1, for this part, we can say that we can have negative infinity, and then we're gonna have negative 1. And we'll have the open interval to show that it's not included. Next, we're looking at this region, and we're not including negative 1 or 1. So we have negative 1. Negative 1 is not included, so we have the open interval. Next, we have 1. 1 is not included, so we have the open interval. Next, we have to look at this region because x can be greater than 1. So all we're saying is that x can be less than negative 1. X can be in between negative 1 and 1, as long as x is not equal to those values, and x can be greater than 1. So that's all we're saying. So here we're gonna have 1 and infinity, and that would be our interval. And what option has this interval basically? Option C. Question 5. The domain of the function f of x equal root of x minus 3 all over x squared minus 16. So we want to find the domain of this function. And notice that this function is like an incorporation from the two previous questions, question 3 and question 4, where we have a square root and we have a fraction basically. And we should know that the expression under the square root should not be negative, so it can't be less than 0. Therefore, since this shouldn't be less than 0, it has to be, the expression has to be the expression x minus 3 has to be greater than or equal to 0. So we're gonna have x is greater than or equal to 3. So that's for the square roots. Next, we move down to the fraction. The denominator can't be equal to 0. That makes the function undefined. So we're gonna have x squared minus 16 should not be equal to 0. So we have to find out what values makes this expression equal 0. So x squared, since we're saying x squared shouldn't be equal to 16, therefore x shouldn't be equal. We're going to square both sides. When we square both sides, we're going to have x should not be equal to positive or negative 4. And yeah, so this is what we're excluding. These values, we're excluding positive 4 and negative 4 from our domain. So let's draw a diagram or number line to represent this. So we have x, we're gonna have 3, we're gonna have 4. Okay, so let's have, this is our number line of real numbers. So we have negative infinity, positive infinity. So we have 3, we have 4, and we're gonna have negative 4. So x should be greater than or equal to 3. So we're gonna have the shaded circle to show that 3 is included, and we're going in that direction, the infinity direction. Next, x should not be equal to 4, positive 4 or negative 4. So we're gonna have an open circle above the 4 and an open circle above the negative 4. So that would mean that any other value can be included. So with these two expressions being represented on the number line, basically, yeah, we'll have to find the intersection. So we're saying that x should be greater than or equal to 3. So since x should be greater than or equal to 3, we're ignoring this side fully. So we're finding the intersection. So all we're seeing is that x should be greater than or equal to 3, and x should not be equal to 4. So let's just have the interval notation for here. So we have 3 and 4. 3 is included because x is equal to 3. X can be equal to 3. So we have the closed interval. So we have 4. 4 is not included here because for x can't be equal to 4, positive 4. So that's what we have. Then we'll have union. Yeah, union. So we have 4. 4 can be included. And of course, x can be any other number greater than 4. So we're going to have that. So this would be your answer. And what option has this answer? Option B. So B would be your answer to this question.